Hello friends, in this video let us discuss the classification of electrical drives. Now, the classification of electrical drives can be done depending upon the various components of the electrical drive system. Now, if we classify our electrical drives according to the design, they are classified into three types. So, the first type you are having is single motor drive. You are having single motor type drive, and the second classification is you are having group motor drive, group motor type, and the third one is you are having multi-motor type. So basically your single motor type drives are the very basic type of drives, and generally they are used in simple metalworking. And household appliances. And whereas your group motor drives are used in modern industries because of various complexities occurring in the industries, and the multi-motor drives are used in heavy industries or where multi-motor units are required, such as you can take the example of railway transport. Now, if we divide the electrical drives from another point of view, they are again classified into two types. So, the classification one is again reversible type drives. One is reversible and other one is non-reversible. So, these mainly depends on the capability of the drive system to alter the direction of the flux generated. So, these are the classification of electrical drives. Now, if we go to the very basic block diagram of our electrical drive, we are having a source. From source, I am having a power modulator, and from power modulator I am having a motor, and from here I am having a load, and from the motor output I am having a sensing unit, and this is sensing unit is going to control unit, and from control unit I am controlling my power modulator, and here I am having a input command. So this is a very basic block diagram for the electrical drive system. Now here the load can be of various types. That means according to the requirements, maybe our requirements are having multiple conditions and specific requirements, our load can be of various types like fans, pumps, blowers, etc. And mainly here we shall discuss about the source, power modulator, motor and the control unit. So if we discuss about the motor first, let us say electric motors. Now, there are various types of electric motors available. So, if you divide the electric motors, they are broadly classified into two types. One is DC electric motors and other one is AC electric motors. So, now again your DC electric motors can be classified into four types. So, one is series wound DC motor, and you are having again shunt wound DC motor, and you are having again compound wound DC motor, and here you are having permanent magnet DC motor. Now, this is the classification of your DC motors. Now, coming to the AC motor, we are having here one is induction motor and the other one is synchronous motor. Again, if we classify our induction motor, they are of two types. So, one is, you can say the squirrel cage type. squirrel cage type, and the other one is wound rotor, or you can say slip ring induction motor. Now again, our synchronous motor also can be classified into two types. So one is permanent magnet synchronous motor, and the other one is wound field synchronous motor. Apart from these, or besides of all these motors, we are also going to the stepper motors and switched reluctance motor. Now that means here we can see there are various types of motors available in our electric system, and each motor is having its own specifications, and they are all used according to their specifications and uses. Now when the electrical drives were not so very popular, for where the constant speed or fixed speed was the only requirement, we were using only induction motor and synchronous motor for fixed speed applications, and for variable drive applications we have gone to the DC series motors. Now as the electrical drives became popular, we have went to the induction motor and synchronous motor. But when electrical drives were not popular, what happened is we have gone for DC motors for variable speed applications, and for fixed speed application we have gone to induction motor and synchronous motor. But as we know that the induction motor of the same rating of DC motor have several advantages over the DC motor of same rating. So the advantage of induction motor over DC motor of same rating are, the induction motor are having lighter weight. They are having lighter weight is one advantage, and they are having lower volume. That means the size of the machine is smaller, and they are having lower cost. Apart from this, there is also less restriction on the maximum voltage, speed and power ratings. Now, as we know that these are the several advantages of induction motor over DC motor of the same rating, induction motor have rapidly replaced the DC motors, and there is one more advantage of induction motor is the induction motors are mechanically stronger and less maintenance is required for induction motor, because there are no commutation or brushes required in the induction motor. So induction motors have rapidly replaced the DC motors. Now when considering the synchronous motor, that is both we are having synchronous motor, the permanent magnet synchronous motor and wound field synchronous motor, they are having full load efficiency and higher power factor for the same rating of induction motor. Now if we consider the synchronous motor of the same rating of induction motor, the advantages of synchronous motor over induction motor is the full load efficiency and the power factor, but on the other side we are having the size and cost of the synchronous machine are higher than the induction motor. So there are several advantages of induction motor, advantages of synchronous motor, but the size and cost of synchronous motor are higher than the induction motor. So basically we are employing induction motor for our loads because of the various advantages offered by the induction motor. Now apart from this, we are also having stepper motor for position control and switched reluctance motor for speed control. Now apart from all these motors, we are also having brushless DC motors. If I write it here, brushless brushless DC motors. These brushless DC motors are similar to the permanent magnet synchronous motor. So these brushless DC motors are now used for servo applications, and nowadays they find an efficient alternative to DC servo motors because there is no requirement of or you can say there are no commutation problems occurred in the brushless DC motors, and its maintenance is easy compared to the DC servo motors. So nowadays they find an efficient or you can say effective alternative for the DC servo motors. So these are the classification of motors and their advantages, and the brushless about the brushless DC motor for replacing the DC servo motors because of the commutation problems, and we have seen the stepper motor for position control, switch reluctance motor for speed control. Now let us go to the power modulators. So what are power modulators? So power modulators are the devices which alter the nature or frequency of the power and as well as it changes the intensity of power to control the electric drives. So those are power modulators. Now your power modulators can be roughly classified into three types. One is the converters, other one is variable impedance circuit, and other one is switching circuits. Now we shall discuss all these three types of power modulators one by one. Let me erase this over. The first type of power modulator is converters, and second one is variable impedance circuits, and the third one is switching circuits. So if we understand about the converters as the name suggests, it converts the current from one type to other type. It converts the current from one type to other type, and depending on the type of function, converters can be broadly classified into 5 types. The first one is, let us say, AC to DC converters. Now here a fixed DC voltage is obtained from a fixed AC supply. So generally we are employing a diode rectifier to obtain the fixed voltage of DC supply. This is diode rectifier, and here we are getting DC, and here we are giving AC three-phase supply of fixed voltage. And the next one you are having is AC regulators. So AC regulators are used to obtain the regulated AC supply, so at fixed frequency. If I say generally the auto transformer of fixed ratio, or you can use tap changing transformer for this purpose. Here to get the regulated AC supply, or you can say here you are having a constant AC voltage and you are having variable AC voltage, but both the constant voltage is also the supply here having the fixed frequency, here is also fixed frequency. We are not changing the frequency, but the voltage is being changed from constant to variable. So here we are having auto transformer of fixed turns ratio. Now the other type is DC to AC converters. So this here we are obtaining the AC voltage from a DC supply of fixed AC voltage, and we are basically employing here power, or you can say PWM semi inverters, or you can say PWM semiconductors for obtaining the AC supply, or you can say for obtaining the AC voltage from your DC supply. So here I am having a PWM inverter or semiconductor inverter. PWM is pulse width modulation. Here what this operation is just opposite to the operation of AC to DC conversion. and PWM inverter is used to invert the current from DC to AC. Here we are having DC supply, and here we are getting AC of fixed voltage. Now the fourth type you are having is DC to DC converters. Basically, from a constant DC voltage or constant DC supply, we are extracting variable DC voltage employing the power transistors or power MOSFETs or IGBTs. Now here I am having the semiconductor choppers. This is fixed DC voltage, and here I am having variable DC voltage. Now the fifth type of converter is cycloconverters. Where a fixed frequency and fixed voltage is getting converted into variable frequency and variable voltage. The difference between the AC regulators and the cycloconverter is, here we are performing the operation from constant voltage to variable AC voltage, that is at fixed frequency, but here the frequency is being changed from fixed frequency to variable frequency, and generally thyristors are being employed for controlling the firing signals. So if I say here is my cycloconverters, and V and F are fixed this side, and here V and F gets variable. So to get variable voltage and frequency, generally cycloconverters are being used, and thyristors are employed to control the firing signals. Now this is all about your converters. Now let us move to the variable impedance circuits. So basically your variable impedance circuits are used for controlling methods or to control the speed of the motor by deploying the resistor or impedance of the circuit. By deploying resistance or impedance of the circuit. But these can be employed only for low cost DC or AC drives. So there can be two or more steps which can be controlled manually or automatically with the help of contactors. With the help of contactors we can control for other motors, and to limit the current flowing into the AC motor, basically inductors are being employed. Inductors are being employed. So this is about your variable impedance circuits. Now coming to the switching circuits, these switching circuits are mainly used in these electrical drives, especially because they have various important functions in the electrical drives. The first function is, these switching circuits are used for smooth functioning of the motor. For smooth running, you can say, for smooth running of the motor, your switching circuits are being employed, and they also protects the motor during any abnormal conditions. And smooth and protection. And the second function is, they are used to change the quadrant of operation during the running condition of motor. So in the speed torque plane there are 4 quadrants, and if you want to change the quadrants, generally your switching circuits are being employed. And the third function is, the switching circuits are implemented to operate the motor in a predetermined sequence. Predetermined sequence, and to provide interlocking, and also to disconnect the terminals from the supply when the motor is subjected to faults or any abnormal conditions. So these are the basically 3 functions of the switching circuits. Now coming to the from the basic block diagram, we are having other part is control unit. So basically the control unit being employed in an electrical drive system depends on the type of power modulator being used. So these are of various types. Suppose if you are employing a semi-converter type of, so you can say, sorry, this is semiconductor type of converter. then basically the control unit consists of firing circuit which employs linear devices and microprocessors. So depending on the power modulator, your control unit varies. So there are various types of control units, and you can employ depending on the type of the power modulator you are using in the electrical drive system. Now coming to the source, the source can be a single phase or three phase. So basically 50 Hertz AC supply is the most common type of electricity that is being supplied in India for both domestic and commercial purpose. So the synchronous motors which are being fed from the 50 Hertz supply can have a maximum speed up to 3000 RPM, and to get the higher speeds we need to supply the higher frequency to increase the speed of the synchronous motor. Now motors of medium and low power ratings are being supplied from 400 volts, and basically the power ratings of the motor can be 3.3 kVA, 6.6 kVA or 11 kVA motor also being employed in the electrical drives. Now we have seen the basic parts of the electrical drives. One is the electrical motor being employed, and the other one is the power modulators, the other one is the control unit, and the other one is the source. And the load can be of various types depending on the type of requirements and multiple conditions that to be deployed from this electrical drive system. Now if we come to discuss about the advantages of the electrical drive system these days are readily used for controlling purpose. Because they offer precise control of the shaft of the motor. Now apart from the controlling purpose, we are having several advantages of electrical drive system in our day-to-day life. So if I write the advantages here, apart from the controlling purpose, the electrical drive system are available in wide range of torque, speed and power rating. Wide range of torque, speed and power ratings, and they can offer flexible control characteristics in drive system. That means according to the load requirements, these control characteristics can be modified to steady state or dynamic characteristics. Now apart from this, the starting of the motor, the speed control, the gearing, the starting, electric braking of the motor can also be accomplished. Now the third advantage is they are adaptable to any type of operating conditions, that is no matter how vigorous or tough the situation is during the operation of the electrical motor by employing this drive system. So adaptable to any type of operation. And the fourth advantage is they are widely used in the multiple quadrant operations. That means during the running condition of motor, this drive system which are employing the switching circuits in the form of power modulators are used in changing the quadrant of operation. In the speed torque plane. According to the requirements. The fifth advantage is they do not pollute the environment, as they are being supplied from the electricity and they do not release any toxic chemicals, or they do not pollute the atmosphere in the form of noise or anything, so they are environment friendly. And the sixth advantage is they do not need any type of preheating or warming before the starting. They do not need any type of preheating or warming, and they can be started instantly and can be loaded immediately. That means instant starting and can be loaded immediately. Now, due to the several advantages of the electrical drive system, these electrical drive systems are being widely employed in the industries for specific requirements and multiple conditions. And this is all about the classification of electrical drives and the parts of the very basic block diagram of your electrical drive system. I hope you have understood well. Please subscribe to the channel. Thank you.